So we're not describing architecture, we're describing the flow.
Yeah, but China means, who has more
I mean, that's Afghanistan. In Afghanistan, we're supposed to have 47.
true.
I'll take those mafia that stayed in Russia today to the U.S. and saw that. That was the contact. There's very few good things you'll ever hear say about it. But the one thing I can't say is there's no stop. He's no stop.
Then he has all these copycats like mini-me, like that copy for us. I'm the problem.
Most billionaires in a single city is Moscow. Yeah.
All right, I'm ready when everyone is.
Cool. We'll just round us up.
Everybody ready?
You don't ask. Tell.
Don't ask, just tell. We're ready to go. All right, so we're going to be talking about understanding. I guess I got to get really close to this. Yes, there we go. All right, so we're going to be talking about understanding offline Bitcoin and crypto wallets, and we're going to be talking about actually building one from scratch. So first, since this is my first talk in person in a long time, I'm very excited to be able to do this. Show of hands, how many of you have used a modern commercial hardware wallet? It's really good to see all those hands. How many of you have been around long enough to have used an old school paper wallet or a raw key pair encoded in some way, like scratched into metal or anything like that? Also cool. So first, a little bit about me, my background, and sort of like my biases and interests. I'm a software engineer at Microsoft in Pittsburgh. My day job has nothing to do with crypto or blockchain yet, but I'm a back-end and systems engineer working on some Azure storage stuff. On the side, I run ChainTuts, chaintuts.com, which is a YouTube channel. I have articles, and I do some standalone code projects like this. And my whole mission is to help break down and get people to understand the actual core concepts in crypto and blockchain space. So I don't do any kind of financial or speculative stuff. I'm interested in teaching people how these systems work. You know, how does a mnemonic work? How does a blockchain work? And then giving them use cases that they might be able to apply to their own lives. So I want people to understand why I think this technology broadly is so important, and whether you're in law, finance, software engineering, or any other sort of branch of life, why you might find cryptocurrencies interesting and useful. A quick disclaimer on this particular talk, I'm not a cryptographer by trade. I'm a software engineer, so I focus a lot of my work on making sure the code that I'm writing is secure, but when it comes to cryptography, we have to trust the really deep down experts on that talk. Security is a complex and ever-evolving topic, and so you know, I want everybody to understand that even this whole process of using well-vetted commercial hardware wallets can change. So this is a proof of concept that we're going to be doing about building a completely open hardware and open source cryptocurrency tool. First, let's talk about why this is important at all. So I think most of you in the room, since you're crypto OGs and really enjoy this stuff, understand addresses. So an address really starts from a private key, which is a 256-bit random number. That is transformed into a public key using an elliptic curve algorithm. So SecP256K1 is the one used in Bitcoin and most other major cryptocurrencies. And at the end, you do some other encoding, maybe add a checksum, and you end up with a public key hash, which is your Bitcoin address. So this is the public value that you can send money to. And many people that are just getting into Bitcoin don't even quite understand what a wallet really does. What a Bitcoin wallet really does is it generates and secures private keys. Everything else can be generated out or fetched from the blockchain from that information. So when you open up the Bitcoin.com or Koinomi wallet on your mobile phone, or you start up a Bitcoin Core client, what that wallet does is it generates a bunch of private keys and addresses. Now, in terms of actual coin balances and those sorts of things, that is all fetched from the blockchain. It's not something that actually has to be stored long-term in the wallet. So with a full node wallet, that node will download the entire blockchain. And it will take that information, validate that the blockchain that you're downloading from, the node that you're connecting to, is following all of the rules of the protocol. So that means all the signatures are correct, we're following other protocol rules around mining and minting of coins and all of those sorts of things. There are also SPV, or Simplified Payment Verification wallets, that are light clients. They don't fetch the whole blockchain, but they fetch some relevant information from other peers. And some wallets just simply use a third-party API to get that data. So a company might run a farm of servers that are running Bitcoin full nodes and simply providing an API interface that their wallets can talk to get information about certain addresses. And of course, most importantly, if we have some Bitcoin, we probably want to spend it. I know HODL has become the new hot thing, but I love still spending cryptocurrency and using it when I can. And wallets will sign and broadcast transactions out to the rest of the network. So for Bitcoin and other UTXO-based blockchains, they compose a transaction with spendable outputs that your wallet owns, and signs that transaction and sends it out to the rest of the network so that it can be mined into a block and validated. But what we really want to talk about today is the importance of private keys. Again, ultimately, the most important bit of data that wallets generate and store is these keys. We've all heard the term, not your keys, not your coins. Anyone that has a private key that is for a Bitcoin address that has some spendable amount of money on it, they can take and spend those funds. It doesn't even matter if it's really rightfully theirs. All this other data can be fetched from the public blockchain. Again, it's public data. So it's super critical that our keys are both securely generated and securely stored. The main types of wallets that you'll see, and the first one that you'll see, especially if you're new to the crypto space, is what's called a custodial wallet. And those of us that know cryptocurrency well and understand it don't really like these types of wallets very much. This is where a business like an exchange holds all of your keys for you in trust, just like a bank holds your US dollars for you in trust. These are very convenient on and off ramps for fiat, and they do have the best user experience for very new non-technical users. So there's a place for them, but they're really not what we want in crypto, because the whole point is for us to be able to truly hold our own money. And so then you can talk about online wallets. This would be, for example, the Bitcoin.com mobile wallet that I use frequently for Bitcoin and Bitcoin Cash, Koinomi and other multi-asset wallets, and of course something like a Bitcoin Core full node. And the final type of wallet is what we're going to focus on, which is offline wallets. The most common offline wallet types that you're going to see are commercial purpose-built hardware wallets. So this is the Keep Key, the Trezor, the Ledger, etc. They both generate key pairs and they will sign transactions for you and only communicate with your network device using a very limited protocol. And that's what makes hardware wallets so nice, when you have money on a desktop wallet, that money is still connected to all the vulnerabilities that a network computer has, like malware. With a hardware wallet, when you plug that USB device into your laptop to send a transaction, the only data flowing between those two devices is the transaction that needs to be encoded and the signature and all of that, which is constructed by the hardware wallet itself. So it's much, much safer than just a pure online wallet. And the simplest form of an encoded key pair is the type that we saw first. So these were old school paper wallets. So how many of you have seen or used paper wallets? So what these were is this was literally just a encoded, usually in the WIF format, private key and an address, and usually a handy dandy QR code you could use to scan that address to send funds, and ultimately a QR code that you could use to sweep those funds into an online wallet when you wanted to spend it with the private key. You could even engrave key pairs directly into metal or some more robust type of material if you want to have savings for a long term. So why offline wallets, right? They're not vulnerable to the same sort of malware and network-based attacks that you get with online wallets. The keys have to be physically stolen from you by somebody getting a hold of your hardware wallet or your seed phrase from your safe. Key generation becomes much more difficult to observe, which is really important because keys must be generated in a secure way. And they can't create and sign a malicious transaction. So these are designed to only sign for what they know on the device. I'm not intimately familiar with all the protocols they use security-wise there, but it's much better than, say, a mobile wallet where some virus might be able to get access to the keys and broadcast a malicious transaction away from you. And of course, they're resistant to data loss. Anybody here ever lose a cell phone, drop it in the toilet, forget it somewhere? Happens to the best of us. Even hard drive failures or loss or theft from daily use. Like, I'm traveling from Pittsburgh with my handy dandy laptop here that goes practically everywhere with me. This is another vector for me to lose Bitcoins if I stored my money on here, but I don't. I have a purpose-built device for that, a backup seed phrase, both of which stay somewhere safe and don't get used on a day-to-day basis. So here's my idea about this. We've got the Keep Key, we've got the Trezor, we've got the Ledger. They're great products. They're what I would recommend using if you're going to store crypto funds. But you saw that I'm an employed software engineer, right? And I have a side project where I teach people about Bitcoin tech. So I'm a nerd. I don't want to just use one. I want to build one. So this project idea was to see if I could take readily commercially available hardware that's even less sophisticated than a Raspberry Pi, and can I code it to generate Bitcoin key pairs for me? I started out getting into tinkering with microcontrollers last year when I did a talk at the blockchain training conference in Denver, and I made a little proof of work simulation with a microcontroller and LEDs that light up and kind of help explain the concept of difficulty in mining. So I'm not like an embedded expert or anything. This is just taking hardware that's out there and taking some of my coding skills and learning how to build on that platform. There's some pretty serious challenges to doing this specific task though. First of all, microcontrollers are small. They don't have a lot of computing power because they're not designed to do powerful things, right? They're designed to use for home automation and that sort of thing, like Arduino projects that can turn on your sprinklers for you automatically, maybe even if you connect it with your phone or something. The M0 line of Adafruit processors, which I used for my proof of work simulation, the little round guys there, were very insufficient in terms of computing power and even code storage space in that device. The second is we're doing a lot of heavy-duty cryptography here. Most of the cryptographic primitives needed to generate a Bitcoin address from the private key all the way up through the key pair are not readily available libraries on platforms these small. Any programmer can get access to an elliptic curve and a hashing algorithm on a normal PC or even a Raspberry Pi, given that that goes to the operating system level. But for these, I had to figure out from scratch how to get this cryptography on there. And the third and probably most important one for making this project secure is it must have a cryptographically secure random number generator built in, or some way in which to make one. Most occurrences of randomness that you see in computer programs are not actually truly random at all. So if you're playing a video game and you have some randomness involved, like whether or not a wild Pokemon is going to appear when you're fumbling around in the tall grass, they're not using cryptographically secure randomness for that. They're using what's called pseudo-randomness. These algorithms are pretty easy to implement and they're useful for what they do, but they're predictable. And when we talk about key generation in cryptography, predictability is the biggest no-no. We have to use a system that generates true randomness every time we ask it for a random number. And that randomness comes from things like environmental noise. So answering these challenges, the first thing I did was find the correct platform to write this on. So, I don't have any affiliation with this company, I just happen to like their products. I'm using some products from the company Adafruit that's based out of New York. They make a bunch of microcontrollers and hardware that make it easy for people like me that aren't embedded engineers that don't want to pour through C code and assembly to write for small devices. So the M4 platforms, one of them is the Grand Central, which I'm holding right here in my hand. There's even one called the Metro and one called the Itsy Bitsy, and I have the Itsy Bitsy wired up over there as well. These platforms are really nice because they have a robust amount of computing power for such a small device. They could definitely fit on the cryptography code that I needed to make this work. Now, how to get the cryptographic primitives? Well, we, especially in this space, love open source and we use open source. So I use the open source. I went to and found the Trezor hardware wallets libraries. Their firmware is open source, which is what we would expect and hope for a product like that. And they have standalone, very compact and well-written C code for cryptography. So ECDSA, hashing algorithms, and all of that. So I ported some of the Trezor code that I needed over to my platform, and I'm going to explain a little bit more about how that works in a bit. Now finally, how about true random number generation? The platform choice actually fixed this for us. All of the M4 line of processors from Adafruit have built-in cryptographically secure random number generators. So another option, if I didn't have this built in, is I could wire up something like an accelerometer to get environmental noise. So you could maybe shake the device or something like that.
Yeah, question. So the random number generator they have built in, how's that work?
So the question was the random number generator that is built into this platform, how does that work? I am not sure off the top of my head.
Do you trust it?
I trust it as in I trust Adafruit. I think they're a reputable company, and they would generally those use some sort of environmental noise.
So check this out. You might be interested. I was doing the same kind of project, like working with random number generators, and the ADR chips have a couple of timers, and one of the timers, if you actually underload it, will give you a true random number. And there's code is out there, it's all C code, but it's more on a hardware level, so I haven't really tweaked it or really been able to implement it, it's kind of on my back burner, but you just might be interested because it's out there. It's I guess it uses germanium or one of the crystals it uses, but when you undervolt it, it gives you an erratic thing and it's just a random number.
Yeah, that's all a good point. So for those of you on the live stream, a gentleman in the audience was talking about building a similar project, and one of the ways in which he could generate a random number on a platform like this by undervolting a particular interface on the device. I'm not an expert on how hardware CRNGs work, but my understanding is it uses noise, things like literal noise. You can use accelerometers have been studied for this purpose. Regardless, we have a source of true randomness that we can use to generate cryptographic keys, which is very important. And how this project is put together is a little bit challenging, but fairly straightforward. To use the C code from Trezor, what I had to do was build a custom circuit Python module. So Python is a programming language that is built on top of usually a C runtime. And so this particular version of Python, Circuit Python, is designed for these kind of embedded devices. And you can extend any of the built-in modules or add new ones as you like, and I just followed an online guide for how to do that. The application level is actually Circuit Python. So the writing to the LCD screen, requesting new key pairs each time the device boots up, that's all done in Python, which is slightly uncommon for small devices, but great because I'm primarily a Python developer in my systems work, and I find it to be very easy to use and prototype with. The device itself is hooked up to an I2C character LCD screen. So we have a little screen here, and that screen displays the private key and the associated address just in a little loop. For demo purposes today, I have it set up to rotate every 15 seconds. If you're actually copying key pair data from this, you can modify the code to be a minute or 2 minutes to give you plenty of time, and that makes it a little easier. So the supported cryptocurrencies for this project currently are BTC, of course, Bitcoin Cash with cash adder addresses, Ethereum, Litecoin, and Digibyte, which are all the kind of core cryptocurrencies I'm interested in and study. The custom circuit Python module gets a CRNG seed passed to it from the Python layer. So when I start up the device, I use os.urandom in the Python layer, which gets us a secure seed, and I pass that along as an argument to the module function call. This hashes that seed into a private key, generates the public key, and returns the encoded key pair. And that final key pair is encoded in WIF or hex for the private key, depending on the chain. So Bitcoin, Bitcoin Cash, Litecoin, Digibyte all use WIF, and Ethereum uses hexadecimal. And then it uses a chain-appropriate address encoding. So for Bitcoin, I'm doing legacy addresses with this currently. It's base 58, same with Litecoin and Digibyte. I do have support for Bitcoin Cash's cash adder, and of course Ethereum's hex encoding. The Circuit Python layer generates the entropy, calls the custom module code to get that generated key pair, and displays it on an LCD screen. I also hooked it up to a receipt printer, so you could print out your key onto paper if you wanted before you copied it to something more secure, but I primarily have used the LCD screen. So some examples of what the final project looks like wired up. You can use various M4 devices for the core code, and then any of these LCD screens, I have 2 of them now, or even the printer, which I don't use that frequently. But it turned out pretty cool, I think. So what this does, again, is once you turn the device on, it will generate a key pair for you. It'll show you the address, and it'll show you the private key that you can write down, put into something that's hopefully waterproof and fireproof, and keep it somewhere safe. So now let's talk about pitfalls. And we love to talk about this as engineers and as Bitcoin people and cryptographers and all that. The first one that hopefully might have been obvious to some of you in the audience is the single key pair thing. Single key pairs are way out of favor now for storing Bitcoin keys and addresses. It has been for years. You have to double, triple check that you're copying the address and, more importantly, the private key off of this device correctly. And especially with WIF encoding, which is base 58, it's real easy to get mixed up on, like, is that a capital W or a lowercase w, and that sort of thing. The encoding is just not human-friendly for single key pairs. The data can easily be corrupted as well. If you have bad handwriting, you might not be able to tell the difference between an A with a little squiggly and a Q, both of which are part of the standard encoding. If you write it down on paper, water damage, fire damage, all of those things can cause issues. UI and UX on this particular prototype, it shows the key pair once. Anytime you restart the device, it generates a new one for you. Doesn't provide any security recommendations like, hey, here's what you should do with your super secret keys. And cryptography footguns could be in there. Like I said, I'm not a cryptographer, I'm a security-minded engineer. So I try to use trusted cryptography implementations and double, triple check everything with manual testing to make sure this worked well. And I will say, although I no longer do, I put my money where my code and my mouth is and actually stored some real funds on addresses I generated from this device for a while. So I do know it works. Potential future improvements then. Number one would be to upgrade to a BIP39, BIP32, BIP44 compatible seed phrase generation instead of single key pairs. So how many of you have used a Bitcoin wallet recently and it gives you 12 to 24 English words and tells you, for the love of all things, don't lose these, don't tell them to anyone, you know, put it in a bottle and sink it in the ocean somewhere that you can get back to. Modern mnemonics are really, really important for safe backups. It's 12 to 24 words, which is 128 to 256 bits of entropy for the initial seed for the wallet generation. The encoding format is much more human friendly, so it's easier to back up. It's easier to read poorly written backups, and easier to transport, really. You can even transport it in your head if you really want to do that, but I recommend engrave it into metal, stick it in a safe somewhere, those sorts of things. The bottom line is the next step in prototyping a homemade device like this would be to support those modern standards. Some UI UX improvements could certainly be warranted, maybe a warning that says, hey, we're going to show your key pair once, make sure you write it down, make sure you double, triple check it before you send anything to it. We could perhaps, since this is a purpose-built device, store the key pairs in memory to keep in the exact same safe spot as your backup phrase is written down, because the security level there would be the same. From a code perspective, I would want to make sure I update my module and firmware to CircuitPython 5, which is the next level of device, or the next version of the firmware. Or I could maybe even think about moving to a pure Python implementation. I think that this device may be powerful enough to do that, and then you would just have to maybe have some of the trade-offs with Python cryptography and that sort of thing. Unit testing would be a really good thing when it comes to software development. Any kind of automated testing you can build in to make sure you don't screw things up is a really good idea. And I'm open to ideas. I'm always trying to learn and improve, which is why I do this in the first place. I'm fascinated by this technology, and I like to learn it, and I like to teach and share it with other people. So I'd be open to hear what people think about this when the talk is done. So finally, again, the importance of offline wallets. Not your keys, not your coins. You want to make sure that your key pairs are safely generated and stored offline for long-term storage. And yeah, this experiment says that somebody with some coding knowledge can do this. The inner workings of the Bitcoin technology are not totally inaccessible. So if you have some experience coding, you know, there's a lot of things that can go wrong, and I urge you to be careful with real money. But what I wanted to do with this project was encourage other people to tinker and experiment, because not only is it a learning experience for you, it might also help you understand it better so you can teach it. Doing this has been a part of my teaching efforts on my website and giving talks like this. So I have one of my key pair generators up here, hooked into my laptop. If you want to come see it, check it out. This particular device is currently generating Bitcoin cash adder addresses. Sorry, Tone. And the other one is generating Litecoin addresses. But again, my particular version of code, I did Bitcoin, Bitcoin Cash, Litecoin, Ethereum, and Digibyte, because they're all projects I'm interested in. So come check it out. Any questions? Yeah, absolutely. Oh, yep. So to repeat the question for everyone on the stream, he asked if I could make this eventually sign transactions and that sort of thing. The answer is yes, absolutely. Again, my goal with this was to experiment and understand how this all works better at a technical level. And you know, I think Bitcoin has a lot of a community that has a DIY ethos to it. So I thought, why not apply my knowledge to it? The reason that it's only a offline key pair kind of paper wallet in the first place is that was just the first place to start, so as to not bite off more than I could chew at one time. That could be a long-term part of it. My next interest in tinkering with this project, I would like to see, as I have time, to go back and have this support BIP39 and BIP44. It's not just as simple as generating the mnemonic, which is actually fairly straightforward itself. When you come from the mnemonic seed, there's actually a whole new procedure that generates your tree of addresses that is between the mnemonic and the way that you normally go from a private key up to an address. So there's that chunk of cryptography which is covered by the existing code, and I would go back and add what I need to do to make it so that I could just give you a seed phrase, because I think that's a little better and more usable. So signing transactions and stuff is definitely a potential improvement. All of my side projects that I do to teach these concepts are just kind of dependent on time and what I'm interested in putting together in educational material around them. So I don't know if it's something I'll actually sit down and do, but to answer your question, yes, it's a possibility. Any other questions?
So typically I use a live boot, any Linux live boot, and I'll put my storage there. I know like Nano, Tracer, they've had their security vulnerabilities, right? So would there be an advantage to using one of these hardware devices as opposed to using a live boot operating system that I could detach from my computer and keep it as storage?
Yeah, it just depends on what you want to do. So the secure key generation is definitely a complicated topic. I like the idea of trusting that those engineers, and it's built on open source. They know what they're doing, right? It's a purpose-built device for that. If you have more expertise and you would rather go from a live boot Linux system and build something from there, get your keys, on a non-network device. The only thing that I know of off the top of my head is when you start a brand new Linux installation, you often do not have a whole lot of entropy built into the random number generator yet. So even though it is a secure random number generator, you might want to use it for a while, shake the mouse around a lot, type in a bunch of stuff in the keyboard to help seed that number generation. The biggest thing is really, we want this key pair generation to be done offline on an air-gapped device, because the primary vulnerability that we're trying to mitigate with hardware wallets and offline key pair generation, even if you're doing this like diceware, like some people literally roll dice, pick up playing cards and encode that as a private key, is it takes away the possibility that some malicious actor on a network is watching that key generation or watching for predictability in that and trying to regenerate the keys that you're using to steal your money. That might even be a better question for somebody that knows that cryptography a little better than I do, but hope that helps.
That's typically how
Yeah, it's not necessarily a bad approach, right? I just would make sure that it's not connected to a network, and that as long as you have sufficient entropy, and yeah, it's not unreasonable. Anything else? All good? Thank you all so much. An extra shout out to Nathan for having me out. It was really great stuff. So hang around and come meet me, and let's chat. I'll show you the devices. Hope you enjoyed it.